Alright, this is Garth, and here's a problem I made up where we can use the conservation of energy to solve a problem involving collisions. Basically, we want to find out how many sheets of glass we could break through if we launch a projectile in space with no drag or gravity acting on the projectile. Um, and for simplicity reasons, we assume that the projectile is a cube whose face has the same dimensions as the sheet of glass. This just makes it so that we don't have to calculate the pressure on a concentrated point, so that the cube is exerting a force equally on every part of the glass. Um, Assume that our block weighs 5 kilograms, is launched at a rate of 20 meters a second. Our glass weighs 1 kilogram. It's stationary, it's not moving, and that takes a force of 1 Newton to break the glass. Um, so I have a loop here, and this will keep looping so long as the force of our projectile, our velocity times our mass, exceeds the strength required to break the glass. So I have a small formula here. This is for the conservation of energy. So we have our first object and our second object, and they collide. And we should have energy should be conserved, and we should have their sum of their masses times some new velocity. And we want to solve for this new velocity, and that's going to be the new velocity of our projectile after it breaks through this pane of glass. So if we rearrange this equation, we can solve for that and get that new velocity. Um, and I say it's a sphere here. It's actually a cube. Um, so the important thing to note is that I am not I'm not updating the mass here. I'm only updating the velocity, and this is because I'm assuming the glass is going to break away and it's not going to be part of the cube after it's been broken through. Um, so every time I'm looping through here, I calculate the amount of joules of energy that I've lost to break through that pane of glass. And I'm also printing out that new velocity. And let's see how many sheets of glass we break through. So we break through 26 sheets of glass. Starting out, we're losing about 300 joules, 200 joules of energy. And our velocity is slowing down. So after we've broken through our first pane of glass, we've got a velocity of 16 meters per second, and then we go down to 13 meters per second. And then it just it appears to slow down logarithmically until we reach 0 after about 26 panes of glass.